All right, my friends, let's take a look at 25 here. It defined f of x as x squared times the quantity of x minus 2 to the fourth, and the directions were for us to find the derivative. So notice that we have a product of two functions of x here. So you will see me using the product rule. And then within the product rule, when I take the derivative of the second function, since you see a composition of two functions here, composition, you're going to see me using the chain rule when I have to do that part of the derivative. So here we go. All right, I'm going to add more steps than I normally would show just to make sure I'm being really clear. So I'm going to do 1, which would be x squared, that first function, and then I'm going to do d2. So I'm going to do this later. So I'm going to need to take the derivative with respect to x of x minus 2 to the fourth. So 1d2 plus 2 d1. There we go. Just trying to be really clear as to what I'm up to here. All right, and then, so that's product rule. Now let's finish it out. So for d dx of x minus 2 to the fourth, because you see a composition of two functions, we're going to need to use what's called the chain rule to get the derivative. So we're going to have, for this derivative, the derivative of the outside function times the derivative of the inside function, which I guess is just 1. So that was a little non-eventful. Got all excited for nothing. And then over here we'll have x minus 2 to the fourth, and then d dx of x squared is just 2x. There we go. And then from there, it's just a matter of simplifying it in a way that makes you feel happy. So you could write it as 4x squared times x minus 2 cubed plus 2x times x minus 2 to the fourth. This is one version of the answer. They may have factored it in the back of the book. I haven't checked, but another version would be where you factor out the greatest common factor, which would be 2x and x minus 2 cubed. So what would I need to multiply that into to get the first part back? I need to multiply it by 2x, it looks like. Is that right? 2x? Yes. And then I need to multiply it into x minus 2 to get the second part back. And then I could just simplify that, this piece right here. What would that be? 3x minus 2. There we go. So here is a factored version of the answer. And hopefully that matches the back of the book. I haven't checked. All right, let's see, number 29. Let's take a look at that one. Okay, 29 says y equals x over the square root of x squared plus 1. And let's diagnose this one. We're going to need to take the derivative with respect to x. And on the right side, I'm going to use the quotient rule. So you're going to see me do low, d high, minus high, d low, all over the bottom squared we go. But when we take the derivative of the lower function, you can see a composition of two functions there. So you're going to see me use chain rule for that. Okay. All right, so let's get started. dy dx would equal low d high minus high. And then I'm going to go ahead and give an IOU for the derivative of the bottom. So we're going to need to do d dx of the square root of x squared plus 1. We'll save that until later. And then all over the bottom squared we go. There we go. So I think off to the side, I'm going to work on this derivative that you see here. So this part. So d dx of, first let's think of it as x squared plus 1 to the 1/2 power. And then let's go ahead and use the chain rule on that. So this derivative would be 1/2 times x squared plus 1 to the negative 1/2 for the derivative of the outside, and then times 2x for the derivative of the inside. I'm going to go ahead and simplify this now. So the 1/2 and the 2 multiply and make 1, and then I'd have x as the numerator and then the square root of x squared plus 1 because of that negative 1/2 power. So taking this and putting it back in, we would have square root of x squared plus 1 minus x times x over the square root of x squared plus 1. And then all over, and then let's go ahead and square that bottom out. You just get rid of the square root, like so. Pretty messy still, so let's clean it up. So starting with this piece right here, like so. And then I think I'll get common denominator up here on the top. So getting both fractions over x squared plus 1 would mean I'd have this. And then subtracting these top fractions, I'd end up with just positive 1 over the square root of x squared plus 1, and that's all over x squared plus 1, which is over 1. And then I'll just flip and multiply. So I'll end up with 1 over basically square root of x squared plus 1 times x squared plus 1. And they could have written it like that as the final answer, but they could also rewrite that denominator as like x squared plus 1 to the 3/2. Since you have a 1/2 power multiplied by something to the power of 1, the same base, you could just add the exponents there. Let's see, what were we calling this derivative way back when? Oh yeah, dy dx. There we go. Okay, one of these last two steps should have done it. There we go, my friends. Hopefully that makes sense. Notice we were done with the calculus really early on. It's just kind of the algebra that keeps on going.